Alright. So to help me out today, I've got something interesting for me. Maybe I'll actually make some straight lines for once.
Oh, what?
Oh, yeah. Alright. So a little thought process here.
No.
This is going to sound like, I want you to realize this right now. There are no proofs in this section. Because the minute I say something I'm going to say today, I'll say something like SAS, or SSA, or SSS. Does that sound at all familiar?
Yeah.
Does that sound familiar?
Yeah.
So we're not doing proofs. We're just referencing those situations. Right? Because remember, side angle, side proof. You guys remember doing those in geometry?
No.
Personally, it's a true statement I just made, but so if I'm trying to build a triangle and I'm given certain things, like sometimes I'm given what the angle's supposed to be, sometimes I'm given what some sides are supposed to be. So for example, if I was given, let's say a side, an angle, and then another side, how many triangles can I make from that?
3.
No. Careful. If I'm given this angle, I'm given this side, and I'm given this side.
1.
How much flexibility do I have in the unknown stuff? I don't have any flexibility, right? The only possible way to finish this triangle off is to do... You got a straight edge, Jeff. Is to do that. See, so giving you... This is the situation of side, angle, side. You see how the angle is in between the two sides in the name? So visually, the angle's got to be in between the two sides. So if I'm given a side, the angle, and the side, there's only one triangle that can come out of that. And this is an unknown, but all I got to do is somehow figure out what that length is, and then these angles have to be set. They don't have any other options besides that. So we still have to figure out how the hell do I find those? Because in this section, in the next couple sections, we're going to be doing something called solving a triangle. So I'll give you these 3 things, and you have to figure out everything else. Now, what could possibly be wrong based on what we know right now? What's the only kind of triangle we can work with?
Right.
And this is not, I put a little, I just put an angle. That's not a right triangle. It's close, but it's not. And it doesn't have to be. It could be any angle, really. So we've got to figure out how do these trig functions that are based on right triangles, how do they work in so that we can use them for other triangles? Section 6.5 is all about 2 types of these triangles. So this is one that'll work in 6.5. Section 6.6 is what I call beefing up Pythagorean theorem. So Pythagorean theorem only works for right triangles. We're going to come up with a more general theorem that works for every triangle. Some of you guys are like, I didn't really need that in my life, but too bad, you're going to get it. So here's just immediately to show you, because this is a little bit of a weird question when I ask you how many triangles can you make. You're not really sure what to feel about it. Let me show you a situation where it is more flexibility. Bless you. And normally this one's called SSA. So what would that mean?
Side angle.
So where is the angle? Is it between the two sides? No. So I'm given like this side length. Let me see how I want to set this up. Let's do it this way. I'm given this side length. I'm given this side length, right? And I'm given this angle here. So I know this line's got to be here like this somehow. But then this side length is given to me. Now this gets interesting. Now, are you guys okay with me so far?
Yeah.
I drew that as a dotted line because that's not a side I'm given. I'm given the side A, and then given the side B, I haven't put B down yet. So here's B just sitting over here waiting. I haven't put it in there yet. And I could put now the only angle that's set is this guy. So how could I put B in here? I could put B in there like that. I could put it in there all these different ways.
Yeah.
You guys still row with me so far?
It's easier to demonstrate with the compass. Because then you can have this.
I'm going to use the props I came up with in my office this morning. I did used to have a giant compass for the board, and it somehow disappeared. I think at one point it got demolished. Poor little dude. So if this, depending on the length of this guy, let's say if he was exactly this long, that's the only way it would fit. If he was exactly this long, if I couldn't move him anywhere else, he wouldn't really reach all the way down to this line. I'm going to make sure everyone's with me. I know this angle. Do I know how long this side is?
No.
No, but I know the side has to be here.
Yeah.
So if this B is exactly this length, there's only one triangle that can come out of this. That one. But if that B is a little bit longer, if that B is right here, then it could swing this way and it would work.
Mm-hmm.
Then it would be like this. Or it could swing this way and it would work and it would be like that. There's a much better picture in the book of this. I just want to give you a little board simulation. But if you look on page, if you have the book, look on page 471. And the way I remember this situation is instead of calling it the safe SSA, you just go ahead and call it the ASS. Because it's got two possible answers. We could actually have no answers, one answer, or two answers.
So it's the ass.
It's the ass of the group. Exactly. So that makes more sense. So the reason they call it SSA is just to be careful. You teach them as a high schooler, so you got to be careful. Right? Even you guys got to be careful. But now it makes sense. Call it an ass because that'll make you remember, oh yeah, that's a situation that I got to be careful about. And the reason, the math of this, what's weird about inverse sine? Or actually any inverse trig function really, but we'll see especially inverse sine has a problem. What's inverse sine's possible output? What's the range of inverse sine?
0.
0.
Who's saying that? Good. Negative pi over 2 to pi over 2.
Oh.
You just got to think back, how did we have to restrict sine to even be able to get anywhere with it? We had to restrict it from negative pi over 2 to pi over 2. That was the domain of the original function, so that's the output. That's the range of the inverse function. How are we doing? So in the process of solving these triangles, we're going to have an inverse sine of something that could be 11 degrees, or it could be the reference angle of 11. It could be 169 degrees, right? So that's where, mathematically, that's where the two possibilities for a triangle come from. Yeah, maybe. So these are the two that use what's called law of sines. And we'll see why it's going to make very much sense as to why certain situations can use law of sines. So let's come up with this law of sines. Now that we've got a little background of what we're going to use it for, let's actually get what the hell it is. Okay. So you guys help me out. If I had this triangle here, let's make it a little less isosceles. They label some of this stuff here and call this A, B, C. So on the practice test, you saw this. I was trying to get you ready for this. They're going to reference triangles like this all the time. Side C is across from angle C. So let me put it inside. Side B is across from angle B. Side A is across from angle A. So we stop right there. That's a horrible triangle. Let me do it again.
You have a straight edge.
I've got a straight edge. I'm not used to it. And neither are you guys. You're not used to me drawing straight lines. Thanks for the support, guys. Okay.
You can do it.
Very much. You can do it. All right.
Can he try it?
There it is. All right. Yeah. Okay. So now I got all the ABC crap out of the way. I'm not going to label this thing all the way. Here's H. Now let's label the sides. A, B. Let's keep it the same. It doesn't really matter in general. Let me just keep it the same for now. So when I drew that height in, what did I make that were totally
Right triangle.
I made the right triangle. So I can actually use that to prove the law of sines. Because this triangle originally is totally not a right triangle. But when I draw that height, we've done this before for the area formula. Right? And that's an actually alternate way to do this proof that I'm about to do. I just like this one. It's a lot more straight, to the point. Can somebody help me figure out what H is? Let me give you some angles. So, I mean, you got this angle. What angle is this? This angle C, right? It's across from C. This is angle A, right?
Yeah.
So somebody come up with an expression that represents the height. So look at this little triangle here. Let's see. Let me draw this. Here's this right triangle here. Is that cool? So this is A, this is H, and this is angle what? C. You stop right there. So we're with me? So I've just drawn this side of it, that one right triangle by itself. So how would you represent, what relates those? And why can't I label this guy?
Sine, because you don't know that language.
Because B is the whole thing, yeah, exactly. So these are the things I know for sure about this little right triangle. And what relates those things?
Sine.
That's crazy.
Oh.
So sine of C equals,
H over A.
yeah, H over A. Cool. Now, of course, do the same thing for the other skinny little triangle, this guy. So this gives me this. If I look at the other side, this guy here, skinnier than that, but it's too bad. Here's C. What angle is this?
A.
A. And here's H again. Now, what does this little triangle say about H?
Sine. H
The
over
sine of
C.
A equals C. I like it. So cancel H out between those two. I think they do this in here. Well, no, they do it the other way. That's right. Shouldn't be too bad, right? You saw one for H, you plug it in the other guy.
Yeah.
You're there, basically. You just want to put it in a certain form for the law. For the law. So if you solve this, you get A sine C, you plug it in there, so you get like sine A equals A sine C over C, right?
Yeah.
Now to make this a little more symmetric, so are you with me on that? Did you guys see that? Solve this for H and just plug it in the other dude. To make these a little more symmetric, divide by A. So I get sine A over A equals sine C over C. Always make your angles uppercase and your sides will be lowercase. Look, the look on some of your faces, you're like, I like this already, Jeff. You stop it, yes.
So you're solving the first one for H?
Beautiful. So, no, for H, because H is the thing I don't care about. H is the thing that I kind of made. Is it a part of that triangle truly? No, it's an interior kind of thing. I want to just talk about the sides and angles of the triangle. So I want H out of there. So if I solve for H, I get A sine C, and then I plug that there, and that's how I got this. Yes, sir?
What about the little a under the sine A?
I got it.
Where'd that go from?
What about it? It was here, so I just divided it down.
Okay.
Now here, the next step, hopefully you guys can take without us having to do all this again. If I would have drawn this triangle differently, right? Let me see. All right.
Straight.
This is really putting my drawing skills, and I use that word really loosely, to the test here. If I would have put A at the base, for example, if I would have put A at the base, oh, let's see if I can do this. So then this would have been C. All right, that's good. And this would have been B. All right, anyway. That's nowhere near, but sorry. So if I just turn this thing around, then the height would have been here, right? And I could have done all the same stuff. And we would have gotten sine of B over B equals sine of A over A. If I do the same exact stuff we just did, I would have gotten sine A over A equals sine B over B. And what else is sine A over A?
Sine C over
Yeah,
C.
so this is the law. This is the law of sines. This. And this is the first and only time you could use a string of equal signs. This is one of the few times you could do that. So if you're still doing a string of equal signs, it's killing you. Don't do that anymore. So, on one level, I don't know, I think maybe some of you guys kind of came with me on this little derivation. It's not that big of a step. This is not big of a step. This is all old stuff. All of this is old stuff. What we've done now is we started with a non-right triangle, drew the height in so we could work with the old ideas of trig, which is not old ideas, but just the way we look at trig was right triangles. And now we've got this rule that works for any triangle. Because definitely that triangle I drew was an arbitrary triangle. Right? It's arbitrary in so many ways. So, one thing is the derivation. The next thing, of course, is the use of the damn thing, and that's going to solidify things a little bit for us. So let's try to use this. Let's use this, of course, let's start off with a nice SAS case. Or, so, side angle side means I'm going to give you a side, the angle between two, and then another side. So let's say this is 7 and this is 13. And let's say this angle is, what's it look like now? 51 degrees. Yummy, yummy, yummy. So, sometimes the book will give it to us like, the book might say little b is 7, little c is 13. And what's the angle in between got to be? What letter? A. Yeah, it's got to be A because it'd be across from the last side, which is A. So they might give me this in the book. You with me? So they might set up the sides. Or they might give me a picture and then I can just label them whatever the hell I want to because the law, A, B, C is kind of arbitrary. It doesn't matter who you call what. You guys see what I just said? Mm-hmm. So it doesn't matter who you call A, B, C anymore because the hypotenuse is an idea that doesn't exist in non-right triangles. So who cares what you call C? So some of them will give you this, so you have to set it up, and then you know the sides, or they might give you this visual, and you can call them whatever the hell you want to. And the instructions will say, solve the triangle. Well, I personally love that phrase, because you're like, do I have to psychoanalyze this triangle? Can you tell me about your mother? No, that's not going to work. So all I'm meaning by solve the triangle is finish it off. Tell me what the last side is, and tell me what the two angles are. That's what we would have to do. Did I just give you? Yes, I did. Oh, I love it. I think you even said this, and then. So here's the giveaway. I love the fact that I'm not taking up attention. This one is a little preview for the next section. Why? Let me pretend like I did this on purpose. So if you were given this, why do you know you can't use law of sines? Because to use law of sines, I have to be able to make at least one ratio. I have to know somebody's angle and their side. Do I know that here?
No.
No. All right, good. So that was a beautiful mistake. I love it when they do it. So this is going to be section 6. It's my bad. But that's illustrating the fact that if I give you a triangle to solve, on a test, I'm not going to tell you which situation you're in. The quick way to tell which law to use is, can I make this ratio? If you can, sines. If you can't, law of cosines. Right, that's why law of cosines exists, is for the situations where I can't make that ratio. So what situation could I make that ratio for?
The ass.
Yeah.
I'm trying to stay with it. For right now. The other situation I could use would be side angle.
You didn't say that though.
I know. I only gave a couple of situations really. So I could have like side angle. Side is one we. Side is beautiful. You could. Why could you not use law of sines for side? I don't have any angles. Yeah, so that's. But it's totally solvable. The one we wouldn't do is AAA, right? Because if we give you all the angles, what could the triangle be? It could be anything, just zoomed in or zoomed out. So there's not enough known in that situation, right? That's the one situation we cannot do. And page 469 gives you pictures of all the different situations. So let's try this one. Now, I want to do this one before the ass one. Because the ass one, of course, gets weird. That's why we call it the ass one. Okay. So this guy if I give you one side, and I give you two angles. Alright, so I give you, how am I set this up? This angle, I want to set this up. Alright. Yeah, I could do that one. Yeah, I could do that. So this one, so I can give you this angle here. It's just going to be a little weird to try to draw this. And this angle here. So I give you those two angles. So I give you, like, this is, let's say 11 degrees. So it's a little tiny angle. And let's say this guy is, what are you going to say, Jeff? Let's say this guy is 51 degrees. What I wanted to use earlier. Yeah.
Isn't that ASA?
No. No, it's angle side. Yeah, it's angle side. What am I doing? Ah! It's a little weird to try to draw this. That's why I want to give you a picture. Oh, that's fine. I can do that one instead. Let's do that one. That's easier to draw from the angle. Angle, side, angle. It works the same way. Okay. So I'm giving you angle, side, angle. So that makes sense visually because the side is going to be in between the two angles. Why is this one going to have just one possible answer? Because
The other angle.
yeah,
Other angle
this could only be here, and this could only be here, and they're going to intersect at one point. That'll be the triangle. Does that make sense?
Yeah.
So there's only one triangle that can come out of the situation. It's not the bad situation. So let's kind of like dot in some sides here. So I got some stuff to talk about. So what do you want to call? It doesn't really matter. What do you want to call this side?
B.
B. I like it. So this is angle
B.
B. Crazy. And then we'll call this angle A. So this is little A. We'll call this angle B. C. It's the last one left. That's C. Cool. So we need to figure out angle B, and we need to figure out the last two sides. So what ratio can I set up here? So let's see, let's try one out. So let's see, if I have sine A over A equals, and what is it about B? What do I know about B?
50, it'll have to,
180 minus 62.
Beautiful. So far I got 62 degrees, so this leaves 118. Good. Obviously not drawing to scale. If you expected that, I don't know what to tell you. So let me start. Which ratio can I fully create?
sign the B.
The B's, right? So I have a side for B and an angle for B. So that's what tells me I can use law of sines.
Yeah.
So sine B over B equals, it doesn't matter. We'll do A first. So now just fill in what you know and solve. And of course, in this case, you got to be careful. The calculator's got to be set in degrees, just because they gave us degrees. Right? So most of these will be in degrees. Let me see if I can do this with Does anybody got it?
No.
Oh, wait.
1.5.
Okay.
Yep. I like that. is brave. So if I say round to the nearest hundredth, I have to tell you how to round these. These will almost always come out to some kind of never-ending decimal. So that's 1.51 that side, and the only thing we have left to figure out is... Now what I hate is when people get to this point, they've done everything beautifully, and then they do Pythagorean theorem to figure out the last side. And of course,
It's not gonna be,
that's the whole point of this section, these two sections, is it's not a right triangle necessarily. It might be, some of them might come out with a 90, and then you can attack it with old stuff. No problem. Right? I'm not going to fault that, but this is totally not a right triangle. The Pythagorean theorem will never work. So to get side C, I just have to do the same thing that we do. And I'm always pretty much, I try to use what I knew from the beginning was right. So I'm not going to use my A I just found. For two reasons. Maybe I made a mistake and it's wrong. And the second reason is I rounded this. So I don't want to use that rounded number in the middle of my operations. So I go back to what I know. So sine of 118 over 7, I can use that ratio over and over. Equals sine of 51 over c, little c. And then just do the same work you just did to figure out what c is.
6.16.
6.16. And why does it make sense what we figured out? What's the largest side?
The edge opposite of the,
Yeah, the largest side is across from the largest angle. Second largest side is across from the second largest angle. So, I mean, that's a quick way to make sure that it makes sense what you got. Does it make sense? Yes.
I have a question.
Yes.
You know how you use sine and 100 to always say, like you use the same ratio?
Yes.
Can you use, since you found out the little a, can you use that ratio and then do the c, sine c, or no? Or does it go to that?
Two reasons I wouldn't.
Alright.
Let me say this again. One reason is because I might have made a mistake here, right? And maybe this number's not right. And the second reason is, even if this number's right, it's not really right because I rounded it. So I always want to go back and try to use what I knew was right from the beginning. Because then if I get one thing wrong, maybe I'll get the other one right. But if I base it off of a wrong thing, I ain't got a chance. All right? You guys with me? Now, technically, Ronald, you're right. You could. Nothing really wrong with it. If you could put that in memory so you don't round it. Just be careful. All right. Okay. Let's try another one. See if I do any better. Maybe I'll take one out of the freaking book. Let's see. Blah, 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 blah. So the other one I want to try is like side. Yeah. Side angle. Let me see if they give me one of those. There it is. Beautiful. So look at number 4.
the example.
Let me put it up here on the board. Not example 4, number 4.
In the board.
Yeah, no.
What page?
Section 6.5, 473. So they give me this angle, so they give me a triangle to work from, which is always nice. This angle is 37.5 degrees. This angle is 28.1 degrees. Do this. That's what it says. Angle, angle, side, or side, angle, angle, however you want to look at it. Now the funny thing, now I want you to realize, I don't know if you guys can tell why it's a little weird to try to draw this anywhere near to kind of nice. But it's nice to kind of have a triangle already drawn. What's weird about this is what can I immediately get without much work?
The other angle.
So really, all side, angle are actually angle, side, angle. They're the same thing. Because I can get that last angle, can't I?
Yeah.
So technically, they told me angle, side, angle. So it's the same thing that we just did. So what is this last angle?
114.4.
114.4.
That's what I got.
Okay, makes sense. Looks bigger than 90 at least. Yeah.
So the picture will, like, be easy for us to tell, though, what's the...
Well, not necessarily. I think the book tried to do it so that it is, but don't take the picture to be to scale in any way. The same way you should do for any standardized testing, right?
For that one especially.
Anything I've drawn, hell yeah, don't take it. I mean, my 118 degree angle is less than 90. Yay, Jeff. So that's more of a, it's bent. away from us, so we can't see what the angle is. Right? Third dimension of the board. Why not? I'm allowed to do that. But when the book gives you a picture, that's kind of nice. You got a nice thing to work from. So we got that angle. We have to figure out these two sides. And labeling things is not overly important, but it kind of anchors you a bit. But what ratio can I make?
Sine.
Say sine A is 37.5.
All right, if you want to label, so let's call this A. So this will be side A. We'll call this one B. So this will be side B. We'll call this one C. So this will be side C. If you always want to call your C the biggest angle, what the hell? Sometimes you won't know what the biggest angle is going to be. So tell me again. Be specific now.
Okay.
Sine A. So that would be 37.5 over.
17.
So I can use this a couple times. That's the thing I know for sure is true. And I can set that equal to either of the other two situations. Sine of
114.
yeah, 114.4 over little c. So this is allow this to be nice, especially when they give you a picture. Makes everything a lot easier. But allow this to be nice. You know when to use law of sines when you can actually make a complete ratio. That's what law of sines is all about, is those ratios. If you can't make a complete ratio, you can't use law of sines. Very straightforward. Doesn't happen often in math that it tells you which method to use. So solve that just like we did a minute ago. Maybe I should do it with you guys. I love you guys. So again? Beautiful. I like it. So 25.43. Okay. Sometimes I might actually give these units, so be careful. Right now they're unitless. Yes?
What's the easiest way to plug in those numbers to get C in the calculator? Sorry, I should have said
Well,
that.
what I do, multiply a C up, and then 7, so you get C is 17 times this.
Okay, yeah.
Over, one more one in there, good, over this. And some of you guys might realize, I want to point this out if you haven't, if the law is this, alternately the law is this, and it's the same damn law, right? And some of you guys might realize if you set it up like that, your variable's already solved for, sometimes. It depends on what you don't know. So that's another little thing you can do. But solving this, hopefully, is not a problem, right? Should be able to solve this. I still have too many people that divide by that and suddenly C is solved for. How the hell did you do that? C is down here. Don't make that kind of mistake. I mean, at least cross multiply if you want to go back to that to begin with. So, what do you guys get for this guy? Oh, that's the one we just did. What is the last one I can set up?
Sine A over A.
Yeah, so now I get sine
280
28.1
over B.
over
Yeah. That's what I got.
and this should be the biggest, smallest middle answer?
Smallest.
Smallest, because it's got the smallest angle. So far it makes sense. That's the biggest. That's the next biggest. So far, this should be below 17.
It is.
What do you come? What say it again?
13.15.
13.15? So you guys getting? Cool. Alright, sweet. Good. So that's nice. Let that be nice. If you don't even want to think about angle, side, or any of that, you just look at the situation you're in. Can you make this ratio? Yes, law of sines. No, law of cosines. You don't have to remember angle, side, and side, angle, whatever, if you don't want to. If that brings back bad memories. So let's try the one I've been avoiding. I just wanted to get us used to how this works before we do this. Notice, a real big reason why this only has one outcome is because nowhere in here did I have to take an inverse sine. I already knew all the angles, right? It's when I take an inverse sine, because of the fact that it comes out with a reference angle type deal, that there might be two situations. There would be one where the angle is small and one where the angle is big. First quadrant, second quadrant. Okay, good. All right. Jeff, don't do it. So let's see. So I want one like number 11. That is an ass. So number 11, they have it set up for me already.
That was funny.
Okay, 68. So they already gave me the angle names. So that's A, there we go, B, C, so this is going to be a little b, and this is going to be a little c. So you can see this is angle, side, side. And again, you don't have to even think about that, but you do want something that's going to tell you it's a situation where there might be more than one answer. So it's whenever you only have that one angle that you know, and you can use law of sines. Because that means to find one more angle, I'm going to have to do an inverse sine somewhere. Does that make sense by itself? Yeah.
But if that's 12, then that'd be 68 as well.
Yeah.
And
I know, this one's
angle
easy.
would be for
Yeah.
the-
Let's make this one harder. This is 11 star. Yay! Alright. Good point. If I ever did that, which I wouldn't do on a test, because I don't want to give you necessarily an easy way out. Obviously, you could use the fact that must be isosceles. So that one's a quick one, right? And then it's not a bad situation. I already know that angle, which means I know that angle, which means it's not an unknown thing. So let's see if changing that side makes it a problem. Okay. So what ratio can I set up?
C.
Yeah, sine. The only thing I got is C I can do. 68 degrees over 11. And the only other one I could use directly?
B.
Yeah. So, because I don't know anything about A dude, right? So that's equal to sine of B over 12. I always got to be careful. The reason I don't want to make too many of these on the fly is because you can make an impossible triangle, and I don't want to do that if I don't mean to. There are impossible triangles. So, I mean, for example, if I had one like that, this is not long enough to reach anywhere. So if they gave me this situation, it's impossible. You would come out with no solution. Yeah. You come out with sine of b equals 1.2 or something. What's wrong with that?
0.02.
What's wrong with sine of b equals 1.2?
You can have it equal.
Yeah, what sine of b, the most it could be is
1.
1. So that's kind of like the way this problem would say, dude, there's a problem here. You need to have this work, and if it doesn't, there's no way to make the triangle. So what are you guys getting here? I multiply the 12 up,
1.01.
and then how do you solve for b? Let me make sure everybody's on the same page.
Inverse.
Beautiful. So take the inverse sine of both sides. So personally, I just always solve all the way, and now I just in my calculator plug that whole damn thing in. In general, you don't want to round too early in a problem. I know we don't all go boating, and neither do I. But if I'm 1 degree off course, 8 hours later, I am somewhere I don't even know where the hell I am. So if you round too early in a problem, the same kind of thing's going to happen. The error is going to compound. So if you do this, let's see if we get something that works.
It
Yeah, I got
errors
an
every
error.
time.
Make C13.
Yeah, I got to make it the other way. I was worried I went the wrong way with this poor guy.
Yeah,
Yeah.
because it equals 1.
So this is a good example of one that has no answer. Because if I try to do this, 12 times sine 68 divided by 11,
You get
I get 1.01. So I get sine is too big.
Yeah.
Cool.
But if you make it 13, it's definitely so.
Yeah, so let's try that again. Let's make that 13. Actually, let's make it, no, make it 13. Alright. So this is 11 double star. So we'll make this in 13. This is 68 degrees still. B, A, C. So when you get that error, when you do that, obviously that means it's set up so that one side will never connect. Does that make sense? One side is just not long enough to connect to the other side. That's why it's an impossible triangle. So that was obviously this portable dude was not long enough to connect. Where am I at? So this is A, B, C. This is going to be little A, little B, little C. So I can still set up sine 68, but now it's over 13. And I can still have to work with side B, because that's all I know. And now what do? Inverse sine of 12 times this. What do you get?
Approximately.
58.86?
Yeah.
Yep.
Now, here is the check for, there's at least one answer then. Because since I know that angle, I know the third angle, that is a triangle, there's at least one answer. The way you check to see if there might be another answer is if this was a reference angle. And the only place that angles for triangles can exist are in which quadrants?
First and second.
First and second, because the triangle angle is at most 180. It's not even 180, right? Less than 180. So if this were a reference angle, what could the other angle be? So this is the reference angle. What would this angle here be?
180 minus that.
180 minus.
I like it. Yeah, 121.14. You guys with me so far? And again, I've been trying to prep you for this. The inverse sine has this output problem, right? So it could be this or it could be that. Now does that work with that? Meaning, if you add this to this, is there anything left over for the third angle? No. So that's how you know there's only one answer. If this would have come out to be 100, could there have been a second triangle? Mm-hmm. Yes, because then that and this leaves something for the last angle to have. So 121 plus 68 is more than 180. That can't come out with a triangle. So this has one answer. If this reference angle kind of idea here actually came out so that it works with the other angle, you got another triangle. So you got to solve both triangles.
Eesh.
Yeah, baby.
So you have another triangle within that triangle. Like it creates another triangle within that triangle.
Yes, and that's that picture on page... Actually, there's one right there. Maybe we'll do that one next. Page 471 at the top. Yeah, it can swing and hit here, or it can swing and hit there. So there's two options for that guy to fit in. This sucks, but the book you can see what's going on. So finishing this out, yes sir?
I was just curious, why did you put the 0.86 on the others?
Because either this is the answer, or inverse sine might be giving me a reference angle. In which case it would be here, and that would give this angle, which does not work with this guy in a triangle. So there is no second triangle. There is only one triangle. The highlighter triangle.
Wait, so then that answer works then?
Yes.
This answer is fine. Because he works with him totally, doesn't he? He leaves something over. The possible reference angle, looking at this as a reference angle, gives me an angle that would not work. That's where the second triangle would come from. So I'll find one. There's an example that actually comes out right. You got to be real careful how you set these up so they actually get two answers. We'll do one that's got two answers, and I'll show you what I need to see from you. Mm-hmm. Okay. Let's finish this one out. So now we know B is this. That's one thing checked off our list. Approximately. So of course, what's A?
53.14.
Yes. So you just add those, subtract from 180, 53.14.
Yeah. That's what I
Yeah.
did.
Well, yeah, just 180 minus that, right?
That's what I did.
You can't be wrong.
Okay.
Can't be wrong. Nobody's saying anything. They're taking your word for it. And the only thing I don't know is
A.
A. Now, in this case, I pretty much have to use my work, right?
Yeah.
Because I can use the thing I knew from the beginning, of course, but I'm going to have to use this angle that I found myself. At some point, we got to train ourselves. So I can make, what ratio can I make?
Sine of 68 over 13.
Good. The one I could have made from the beginning, the one that we already used once, equals
Sine of 53.
sine 53.14
over A.
over A. And it would be really, really cool if you guys knew how to, in fact, maybe I'll show you. We'll do this up here in the calculator up here, so I can show you how to not have to round. Some of you guys know, I'll make sure we all know. Oh, this is what a lesson is like when Jeff has no time to get ready for it. My whole experience for the last few days has been grading example. Okay.
So then you're not going to have us go like outside of a triangle that you already drew, right? Because like an example D on 471, you can make another triangle, but it'll just be outside. Right, yeah.
Yeah, so it wouldn't work because that angle that they've got is the angle you were given. So if you go out, and that angle is not there anymore. So it's not going to work. So that's another way you could have just one answer. This calculator is free. Calm down. Get down. Let's see. So, real quick. Redoing what we did to get this. It'd be the inverse sine. Where do you go? And of course, let me make sure. Yeah. That's a lesson I learned really the hard way. Inverse sine of 12 sine 68. This is why I like my scientific calculator, because it doesn't have all these parentheses. Divided by 13. So that's where we got that. Here's the button I don't think I've talked about yet. This is a really useful button. See this button down here? STO?
Yeah.
Stow. So stow that in X. Thanks for nodding. So then, to solve for A, multiply A up, it would be 13 times sine of that divided by sine of 68. So 13 sine X. How are we doing? So you guys see what I'm doing? Solving for A, you multiply 13 up, divide that sine 68 down, so it'll be 13 times sine of not X, Jeff, where'd it go? What did I put that?
Because you still have to calculate the other angle, yes.
That's right. So how do I get that other angle?
180 minus 68 plus X.
So it'll be 180 minus
Oh, yeah.
X minus 68. Or if I would have been really smart about it, right when I got this, I could just say 180 minus that minus, what was the last one?
68.
Yeah. And then I could store that. That would make a little more sense. Pop. Alright, so I figure out what that angle is that I have to use later. I get it done on the calculator, so it shows up. So it's not rounded more than the calculator rounds. Now I can use X in this equation. So when I go to solve this, it'll be 13 times sine of X divided by sine of 68. Okay. Is that what you guys got?
Yeah.
So 11.22. And does that make sense? Yeah, the biggest side is across from the biggest angle, middle, lowest, smallest. So it makes sense? All right, let's do one more and then we'll head out. Do you?
How do we erase it?
It doesn't matter. The most you can do is set it to 0,
Being weird.
which is what it comes set to. But it's not going to mess you up at all. So normally people are worried about when they go y equals and like, now my x, no. When you go to graph, the calculator understands that x is not the variable x from the home screen, it's its own thing. It's going to plug in a lot of points of its own. Does that make sense? So don't worry about setting x to something messing up your graphs. It won't. Alright, so let's do one more. We'll do this here. So this is a case where they want you to draw it yourself.
What's both 6.5 and 6.6 today, right?
No.
We're just doing 6.5. Yeah. We're going to do one more example and we're going to head out. So this, let me just give this to you. They tell me that angle A is 43.1 degrees. Side A is 186.2. And side B is 248.6. So if you learn one thing from me, it does not matter if your triangle is to scale. Your triangle that you draw is just a reference point. You let go of it being to any kind of scale. Unless you're truly anal, in which case, good luck to you. Right? It's not going to be easy to do. So I just want to kind of set this up. So obviously I can make B a little bit longer than A. That was almost right, but who cares? So I'm going to say this is B. And I'm going to say this is A. And then this is going to be C. So A is 43.1, that's right there. So your triangle would not have to look anything like mine. It's going to look like whatever the hell you want to set it up as. So this is angle B here, and this is angle C there. Now officially, what situation am I in?
Ass.
Exactly, that's the one we want to talk about, right? So I'm an ASS, angle side side. Alright, and we're going into this realizing there will be two solutions. So we're going to see why in a minute. So what can I do here? What's the ratio I can obviously set up? It involves the A's. Right, because I got the angle and the side. So I got sine 43.1 over 186.2. And of course the one I have to set that equal to is B. Because I don't know a damn thing about C's. Let me stop right there. Okay. So now I got sine of B over 248.6. So do that. It's not going to come out as an error, so it's nothing that's thrown in your face that there's a weird thing going on here. So what you guys getting?
No.
Uh-oh. All right, hold
I
on.
did not get that.
Let me do it too.
65.82.
Yep, cool. So angle B is at least 65.82. Now, if that was a reference angle,
Okay, yeah.
because that could be obviously the output of any inverse trig, you have to look at it, it might be a reference angle. It might not be in the right quadrant you want it to be in. So and the only quadrant it could be in for us, for the physical thing we're doing, is it could only be in quadrant 2, plus it's positive, so that's good. So if this was a 65.82 reference angle, what angle would this actually be?
114.
Yeah, 114.18, roughly?
Yeah.
Stop there again. You guys see where that came from? Okay, there's more head nodders than head shakers, because there's nobody shaking their head. Yes?
So you have to solve for both.
Well, yeah, why is there a second triangle? Does that work with the angle that's in there? Does it leave anything left over for the last angle? Yes, it does, because that plus that is less than 180. It leaves the door open for another triangle to exist. So what I would do then is, I'm going to finish this one triangle out here, but I'm going to immediately put over here, however you want to do this. I'm trying to remember how I used to do this. I think I used to call this B1 and B2, but however you want to do it. So everything with a little 1 dude on it is the first triangle. Everything with a little 2 dude on it is the second. I think I used to also do just a prime on that dude. However you want to tell yourself, this is one triangle, this is the other one. You don't want to mix them up. So let's finish this dude out, and then we'll attack him again. Maybe. So what's true for both triangles? What's true for both? Yeah, the stuff they gave you. This is still the truth. That's still true. That's still true. All that's still true for both triangles. The only difference is angle B could be either really big or it could be really small. See, so I could have, look at this side here. I could swing that side in and it would fit there. That's the other triangle. That's the second triangle. Because then angle B would be different. So actually the triangle I drew is more for like the second triangle. But you don't know going in, so screw that. Okay, so maybe. So what do we have left to figure out for the first triangle?
C.
So for the first triangle, I know this. C, of course, angle C is 71.08. That's about right. And then how do I figure out that last side? Yeah, so I can set up the same ratio I've set up from before. Right? I can use that same ratio because that's the one I know is true. So I know that. Over 186.2. And in this case, I set that equal to sine of... Yeah, 71.08. You can be careful and do like we did up here. In the interest of time, we'll just put this up here. Over C. That's the last side I've got to know. So we just figured out if B is this, we now know what C is. And now that I know what angle C is, I can make its ratio with side C. That opens the door to use the law of sines again. Since I know what that angle is, I can make a ratio between these two. I finally know something about C's. Right? So that's why I was able to set this ratio up now and use it. Before, I didn't know anything about C. So now I can solve for C. If I solve for C, it's going to look like this. Just doing this the quick way. Don't worry too much about the memory. From up plus C up, it'll be 186.2 times sine of 71.08. Yeah, divided by sine of 43.1. Is that what you guys get doing that?
Yep.
Yeah.
Okay, so 257.79 roughly. So that's C1. So we know everything about triangle 1. Now let's look at triangle 2. So B2 would be 114, is that what it's? 1.18. I'm worried to the point where I can't read my hand. So B2 is that. I can redraw the same triangle I had earlier without the purple in it. Right, so just redraw the triangle you knew from the beginning. So now we know this was 43.1. This was 248.6. This was 186.2.
B's different.
And now we know B is 114.18.
Yeah.
And the only thing I don't know now, the last two things I don't know is what's C2 now.
22.72.
Did I make a point of that over here? Yeah, this is C1. Yeah, how do you figure out C2, of course?
180 minus.
Yeah, 180 minus what you got already, which leaves
22.72.
22.2.
72.
The math involved here is remarkably minimal. I don't know if you guys realize that. It is a little weird drawing the pictures from what they tell you. It's a little weird with the check to see if there's a second possibility. You do want to get used to, I mean, the easiest way to know when it's going to happen to you is when you're in this situation, which means you're going to have to know the situations. So you have to come up with a way to tell yourself when you have to check to make sure. Basically, it's whatever you have to do inverse sine. So the last thing I don't know is side C. And now I do just like I did down here, I just put in the correct stuff. So I got sine of 43.1 or 186.2 that we've known since the beginning.
Over sine of
C over little c dude, right? So now, because I know angle C now, I can figure out side C. Do the cross multiplication, all kind of stuff.
I got 105.25.
105.25.
05.25.
Good. All right. I was hoping maybe I trust you, but it's nice to have verification. Okay. And again, you can take a real quick check to make sure if it makes sense. If the largest side is across the largest angle, so forth, to make sure it makes sense. And it does. Thank God. Yes.
You said the triangle. Oh, never mind.
Cool. I can do that. All right, guys. Oh, yes.
So you figure out there's a second triangle in the right. You get
this angle, because that could be a reference angle. Because it came from an inverse sine. So it could be, if it was a reference angle, it would define this angle. And does that angle plus the angle I know leave something for a third angle to exist? If yes, there's a second triangle. If no, there's only one triangle.
equals 180 there.
Exactly. If it exactly equals 180, which would really be evil, because then maybe there's like 0.0001 degree or something. So it's never going to do that for us. It's going to be pretty obvious. If it's less than 180, there's another triangle. If it's more than 180, there's only one triangle. Yeah.
Did I get my?
Yes. Who else didn't get their test back yet?
That's only when inverse, right? Inverse is fine.
Dawson. So the red grade's your average right now, not including homework.
Probably be bad.
Thank you.
Jesse, you got close to your prediction, dude. Not quite in there. So that's your current average there.
What up?
Oh,
But you can bring yourself.
How'd you do?
so in red is your current average.
87.
That's your lowest grade I've ever seen you got.
Rub it in, buddy.
Oh man, that was kind of rough.
That was a little rude.